Hi everybody and welcome back. So today is going to be the last video in this series and it's going to be how we are going to get a 20 out of 20 on our physics IA3. Now, just before I get started, I do want to make sure that this is no guarantee of any marks in any way, and at the end of the day it's your teacher is the one who marks you, and I want you guys to make sure that you are doing what your teacher wants specifically. What I have here is generally what you should be doing, but always check with your teacher, just because some teachers or confirmers or whatever do have like little niche things that they would want you to include. At the end of the day, they're the ones marking you, not me, so make sure that you are always double checking, and let's get into it. Another thing I'd like to say is your assignment doesn't need to be perfect in any way to get a 20 out of 20. It just needs to hit the dot points. And I did find in my last video, I think it was my biology IA3, that there are actually a couple of things that I would now do differently that I didn't think were great, but I still got a 20 out of 20. So I think that is something important to consider. As always, we're going to start off with our easy marks, which are the communication marks. And those are 2 marks and you want to get all of them. Now, again, this isn't my ISMG, doesn't really matter, but this is my assignment. So the first thing I'm going to talk about is the acknowledgement of sources of information. So this is just your referencing. Typically, you're going to do your Harvard or your APA. QCAA actually does not specify what they want you to use. You just use whatever your school policy is. So my school used APA 7, so that is what I used. A lot of the time your schools will provide you with some sort of referencing generator or something for the big ones that should go down the bottom. Just make sure that you are doing it properly. These big ones here, make sure they're in alphabetical order. I have a lot of sources here, but it just ended up that way because of the nature of this assignment. You can see that I think it was my biology IA3. I didn't have nearly as many sources as this. It's just this assignment happened to end up that way. Making sure it's in alphabetical order, it's spaced nicely, and that it starts on a separate page. And that comes into like the genre conventions here. You can't have your reference list starting up here. Technically, I could have because there's more than enough room, but you always should start it on a brand new page. You also need to have your in-text referencing. So, for example, here I've got name 2020, date. You need to reference any figures that you have, and you also need to make sure that you are referencing your evidence. Your evidence should come from scientific journals, but I will touch on that a bit later. We want to have an appropriate use of genre convention. So basically that just means set it out in this same layout that I have, making sure that we are labeling our evidence, we're referencing everything, it all makes sense, the order that we're putting it into, the references are in the right spot. That one is a pretty easy one to get. It's basically just follow the template that is either on the internet or that your teacher has given you. The last one is fluent and concise use of scientific language and representations, and that one basically just means make sure you're saying things in a scientific way. Don't use any pronouns like I's, we's, anything like that. Making sure you're speaking in the correct tense, all of that sort of stuff. Something that I didn't realize would be a problem until somebody actually messaged me and told me that they got marked down for this was that you need to make sure that you are using the correct spellings for Australian English. So this person had used spellings like colour without a U and like realize with a Z. Those aren't the way that we spell those words in Australian English, and this is an Australian assignment, so make sure that you aren't spelling it the American way. Turns out that can apparently get you marked down. But those are our 2 easy communication marks, and I want everybody to get those ones. But let's move on to some of the harder ones. So this is the same for all assignments. We need to have a considered rationale by identifying clear development of the research question from the claim. So what you want to do is you want to start off by stating the claim. All I do is say, it was claimed that this. My claim for this assignment was about how GPS systems would not function without considering relativistic principles. So what I need to do from here to develop my research question is I need to look at each part of the claim and unpack it. So I start off with GPS and I talk about what is GPS, and I say, how does GPS work? I'm just going to put it out there. I hated this assignment. This is the worst assignment I've ever done. I was miserable. I hated it. Hopefully that doesn't come off too strongly in this video. So I talk a little bit about what GPS is, and then my teacher wanted me to include what applications of GPS are. And I just say the function of GPS is to provide the position, including latitude, longitude, etc., etc. How does GPS work? Like this, because this formula here, distance equals speed time, if you know anything about special relativity, that distance and that time can change. So that is why it was important for me to mention it up here, because I mention it again later on. Now, I was talking about how it works. I was talking about something called trilateration. Now, that is pretty hard to imagine. So I found myself a nice diagram that would make it way easier for my teacher to understand, that you've got the 3 satellites and you find like the intersecting point, etc. I made sure I labeled that properly and had my reference. I then talk about relativistic principles. So I spoke about GPS systems there, but I also had to define what the function was. So I say the function is, and I say what sort of applications they have, and then how does it actually function. Our 3 key points here are GPS systems, function, and relativity. So I've done what a GPS is, I've spoken about functioning, and now I'm going to talk about like the relativistic part of this. So I say, okay, time is used to calculate the position, so errors in time measurements will theoretically affect the position that is calculated. Now, I do talk about how apparently these atomic clocks don't account for time dilation, and I then say what time dilation actually is, and then I mention the word special relativity in there just to make sure it is very specific. I then say time dilation due to speed will be investigated, because the claim up here says relativistic principles, and you will know that there's special relativity and there's general relativity, and in year 12 we only do special relativity. So I say time dilation due to speed will be investigated, because that is special relativity, whereas time dilation due to gravity is general relativity, and we don't want to do general relativity. In these assignments we always want to relate back to the actual content, unit 3 and 4 content, as much as possible. Don't do something that is not included in the content. So I say we're not going to do gravity, we're going to do speed. I then talk about what the speed of satellites actually are, and I restate that formula that trilateration causes. I then say, okay, well, theoretically, if time dilation causes error in these measurements, then it's going to cause error in 3 dimensions. I then go, okay, let's calculate the error per day. So I use the time dilation formula, and you always need to make sure that you are defining your variables so they make sense. And I have our error. So I've got how many seconds per day an Earth clock measures, and I've got how many seconds per day a GPS measures. And then I find, okay, there's an error of 7 microseconds per day. And then I can show that if you put that into speed equals distance over time, using the speed of the satellite, which I wish I had mentioned, I hadn't, and you find that you actually have an error of 2.1 kilometers. So I can say, okay, that can actually cause a lot of error over time. I say, okay, corrections have been made to offset this error. So I've said what the error is, and I've said that corrections have been made to offset them. But I need to double check that. I need to look at the data we have and go, okay, are these corrections actually working? So I'm going to investigate how errors due to time dilation will experimentally affect GPS position if we don't include the relativistic corrections. So if we don't include the corrections that are made and used in GPS, what are our results going to be? Because at the end of the day, I want to show that a GPS can't function without considering this relativity. So what's happened here is I've developed my research question at the very end. How does time dilation, so I'm speaking specifically about time, and you can see that I've developed all of that time stuff from the claim. And I make sure that I've described it by special relativity, because we don't want to accidentally move into general relativity. And I'm going to say, okay, how does it introduce error into position measurements of the global positioning system, which is GPS? Now, we want our research question to be specific and relevant. Mine is incredibly relevant, and you can probably see that the claim is GPS systems wouldn't function without considering relativity, and mine is saying, how is relativity going to introduce errors into GPS? So it's very relevant, but we also need to make sure that it is very specific. So here I've mentioned time dilation specifically, because relativistic principles could mean like length contraction as well. I've mentioned special relativity because I could also be talking about general relativity. I'm talking about introducing errors specifically into the position measurements of GPS, because there are a couple of different like minor applications GPS do, if I remember correctly. And then I also just use the full version of GPS. I don't abbreviate it in the research question. So that is a super specific and super relevant research question. The last thing is just the selection of sufficient and relevant sources, and that basically just means reference everything that you get. Make sure that you have enough and make sure that they aren't like dodgy references. So here that was some US government website, some geography thing. I think that was the textbook. I've now learned that you're not meant to reference the textbook, so stay away from that if you can. And yeah, just make sure you do have enough references and you're not just making stuff up. So that is our beginning. You should also have a title. I should have mentioned that, and that title should be as short as possible. But now let's move into our evidence. So what we've got here is we need to identify sufficient and relevant evidence. So we need to find evidence that actually works. We need to identify the relevant trends, patterns, or relationships, and they do say thorough. And we need to thoroughly and appropriately identify uncertainty and limitations of evidence. That appropriate thing there means, okay, you're saying that this is a limitation, but is it actually going to affect our data or our research? So make sure whatever you're saying is actually a limitation and you're not just making it up because you can't find any. It is completely okay to say that there are no limitations. Unlikely, but it is okay. And then at the end of it, you just need to have insightful interpretation demonstrated by justified scientific arguments. So let's have a look at my evidence. So my first evidence, I remember this being a little bit blurry, so I had to touch it up and include, like I had to do the axes titles. Now don't change them obviously, but you can adjust them to make it easier for whoever to read. And I also made sure that I included the legend. So if I remember correctly, this was just showing how as clock error increased, then the positional error increased. So what I should start off with is explaining what this study was actually finding. So I mentioned, okay, this was a simulation. They inserted a specific amount of clock error into GPS, and then they had a look at the horizontal and vertical position error in those measurements that occurred because of that inserted clock error. Now, I do mention this study doesn't consider time dilation, and it's not talking about time dilation, but it's showing how clock error affects GPS. And if you have a look back in my introduction, I said, okay, we've got a largish amount of time error, 7 microseconds, and they are using nanoseconds here, but you can still see the same trends. When this clock error happens, this positional error happens. So I do say, okay, it's not perfect, but it's going to get the job done. I then mention, okay, these measurements were taken at this time, and then I say, what is our actual trend? The overall trend is as clock error increases, the average error increases steadily. I also then start using some numbers and say, okay, well, our overall error ranged from like 3.4 to 5 meters at this time of day, and 4.5 to 6.5 meters at this time of day. Now, you may be thinking, how does this change, like, depending on the day? Or like the time of day, and I actually do talk about that one. So I would mention that, and that is how you get that insightful interpretation, noticing that it's different at different times of day. So it's very, very, very important that you do include that and you do mention it later on. Never mention something if you're not going to come back to it. I then say, okay, it's a linear relationship, and then I bring in my justified scientific arguments. I say, okay, well, the formula is actually distance equals speed over time, which should mean that distance is directly proportional, or not necessarily directly, but distance is proportional to time. And as you can see, in this situation, distance is proportional to time. So that is how I've been very insightful, and I've justified my arguments using science. I say, okay, these results make sense according to this formula. I then say, this is very reasonable because 7 microseconds causes 2100 meters of error. So it does make sense that 7 nanoseconds, which are a lot smaller, causes about 5 meters of error. So I do say, okay, this does make sense. I then say the greatest error was measured at 3 a.m. and the lowest at 6 a.m., suggesting that time of day could affect position error. I then say, I don't know why, and we could further investigate this. Mention it because that is very, very insightful. I then say, okay, something else I've noticed, when there is 0 nanoseconds of clock error, there is still positional error present. Okay, that's weird. I should notice that and go investigate it, because if you don't, then you're not being very insightful or thorough. You should see that there is no error. Well, there is no clock error, but there's still positional error. And then I found out when I read the study a bit more that apparently GPS can't track receivers below the horizon, which does cause a little bit of error. I then say, okay, let's do some maths. If 7 nanoseconds is substituted into the formula, then the distance error should be 2.1. However, the error in figure 2 is higher, but that makes sense because it started off higher to begin with. So I do say that this observation is scientifically supported. At the end there, I just say, okay, we need to have some sort of overall sentence to wrap it all up. So that is how you do an analysis of evidence. And then I've got a couple more. So I won't explain to you exactly what I did, but I think this one was position error in north and east directions, and with and without special relativistic corrections. So the blue was when corrections had been made, and the red was when the corrections had not been made. So that is literally perfect. This is literally the best data you could get for this case. Now, the thing that I did mention here to be very insightful and all of that was that, first of all, vertical error is greater than horizontal error, and apparently that is, again, because of the horizon thing. I then say there are multiple different position measurements rather than multiple of the same measurement, which is possibly due to other random factors that affect GPS. And then I go find what some of those factors could have been, which include atmospheric effects and radio interference. And then lastly, I talk about how there is still error present. Like, you can see that there is, even when the corrections have been made in that blue, error is still there. So that is another thing that we need to make sure that we are considering. I then have an overall statement at the end and say, okay, this is experimental. Just make sure that you are mentioning where you're collecting the data and what it's considering and all of that. And this is my last piece of data, and this one was real data. So this was when a real satellite thingo malfunctioned, and this is just the data that they got from this. I will admit it was hard to find recent data for GPS stuff, and I don't know if that's because maybe we've figured that all out already. Like, maybe we're done with GPS, we've got it good, we've got it all amazing. I don't know. It was pretty hard to find recent data. Both my friend and I who did this found a lot of it was from the 90s and early 2000s and stuff. So sometimes you do have to work a little bit hard to find the data. I then just explained, okay, what was this error? Some decommissioned satellite triggered a bug and it removed relativistic corrections from some satellites. And then a whole bunch of error happened, and the error was actually more than the time dilation error. So time dilation error is 7 microseconds, whereas the error here was 13.7 microseconds. So I said, okay, the other time error might be because of general relativity, because this removed relativistic corrections, not special relativistic. This one up here mentioned special relativistic, whereas this one was just all relativity. So I was just like, okay, well, the extra time issue was probably because of general relativity. I then say what it was, when the bug was triggered, and basically just really analyzing the different devices. I then talk about what the significant error could have been to, blah, 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 blah. Just the same as the other two. Then we would move on to the conclusion. So in the conclusion, you need to have justified conclusions linked to the research question. So those justified conclusions are going to be from your data. We want to have an insightful discussion about how good our evidence was. We want to extrapolate our findings back to the claim and then suggest improvements and extensions. Now, you might have noticed that I didn't speak about uncertainty and limitations after my evidence. I spoke about it in the conclusion. Now, it doesn't matter where you put that, you just need to put it in there somewhere. So in my conclusion, I start off by restating the research question. I want to make it as obvious as possible to the marker and the confirmer what I'm actually talking about. It's way worth it to just really signpost and say, this was the research question. I then use data from all 3 data sets to justify this. I then even use scientific facts to again justify this. Now I have noticed here there is a space missing. Oops, that is my bad. And then I say all trends are supported by scientific evidence, and I have explained that in each analysis. I then say, okay, so this is our evidence, and now the research question can be answered. So I straight up answer the research question, restate some evidence, and then say, at the very end, very concludingly, therefore, clock error in GPS, which can be caused by time dilation, can cause significant position error that could adversely impact GPS users. So that is like my final overall statement. This is what I have found in this article. Then I will keep going and go, okay, quality of evidence. Now, I said my quality of evidence was highly acceptable. Now, it doesn't really matter if you use acceptable or any other word like that. You just need to ask your teacher what they want you to use. So I said, okay, the articles were recent. They were from 2016 and 2018. And then I say, okay, well, GPS was developed in the 70s and became useful in the late 80s, pardon me. So I said, okay, well, this is a current understanding then. Considering how long ago GPS was developed, this is very current information. Because, I mean, if you're in biology and doing genetics, data from 2016 is probably going to be very outdated. But considering GPS was created in the 70s, it's not outdated to have data from 2016. I then say that all articles are unsponsored, and just remember our CRAAP framework. So C is for currency, R is for, I've done this in the wrong way around. Okay, it doesn't matter. R is for relevance. A is for authority. The other A is for accuracy. And then P, I cannot remember, but it's basically the is it biased one. Like, where did this come from, I think? Like, the money-wise. So P, I said that all articles are unsponsored. So, like, there was no money put into this. Like, it wasn't anything dodgy like that. And then say, okay, authority. So these articles were published by the US government, European Space Agency, and the Malaysian military. And I was like, okay, those are all very reliable and they likely have very good equipment and methodology. They're all government agencies. This isn't just some guy like in his backyard. I then say for the relevance one for R, all pieces of evidence were sufficient in answering the research question, and they all brought in different aspects of it. But I did say if any limitations regarding relevance are identified below. I then at the very end said for the accuracy that all studies corroborate. So that does mean like the accuracy is looking a bit better. I then move on to limitations. So I say, okay, let's start off, and I do the limitations for all of them. So figure 2 was a simulation. So I say, okay, well, would that error certainly occur? I then say it doesn't consider relativity, which doesn't directly address the research question, but this limitation is minor because it's showing how clock error affects the measurements, and similar clock error due to time dilation will probably result in similar error. I then talk about figure 4. Now, figure 4 was that other satellite, and it's limited to considering all relativity errors. So time dilation was causing some error, but we don't know like how much it actually was. So that data there showed that yes, it did have an effect on time dilation and GPS measurements, but I don't know to what extent it had an effect. The last thing I talk about is figures 3 and 4, and I say, right, it's real data. Cool. But in real data, there are other factors out there like atmospheric conditions and radio interference that can affect GPS. So I can't say, okay, I cannot be certain about the errors being entirely due to relativity. Majority of it will be, but there are slight other things that can happen that can mean it's not fully due to time dilation. And those are all of my limitations. Now, the last 2 things I need to do are my claim and my improvements and extensions. So in the claim, you need to extrapolate your data back to the claim. So what that means is you need to answer the claim. So what I do is I restate the claim, and then I say blah, 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 blah. And then at the very end, I say the claim is supported because with this error, like we've seen that there was up to 720,000 meters of error when all of the GPS systems, multiple satellites went down, and because these relativistic corrections were removed. That, to me, perfectly says GPS won't function if we don't consider that. I do make sure that I mention all 3 bits of evidence again and just say, taking it back to GPS and functioning and relativity in general. So I can say, yes, the claim is supported. A lot of the time in other subjects, the claim won't be supported or it won't not be. So you'll say, it is supported, but we need to do further research to look at more things. Whereas in this case, it was very like black and white, like, nah, GPS won't function if we don't consider it. The last thing we need to do are the improvements and extensions. So I put 2 or 3 of each. Make sure you have both and make sure you have multiple of both, 2 minimum. My improvements were use more data sets that demonstrate positional error when we remove only special relativity, because figure 3 was the only one that considered only special relativity. So I can say, okay, this will improve the quality of the investigation because then we can check for like corroboration and all that. I then say, to improve it, we should further investigate like the accumulation of time error. So what happens if like this satellite isn't fixed? What happens if over more than one day, like over a week or something, like what does the time error, like that time error is going to get further and further out. So like what effect is that going to have on our GPS? So I say this is going to improve our understanding of time dilation in GPS systems. The very last thing to do is to look at our extensions, and I say, okay, to further support the claim, I'm coming back to that claim, I say general relativity could be investigated. And I justify that. Make sure you justify all of this. I then, for my GPS error, remember all the way back in figure 2, we noticed that different times of day affected positional error. So I'm like, okay, we need to investigate that now. If you're going to mention something, reference back to it at the end. My last thing was to just investigate the effects of atmospheric pressure and radio interference on GPS and time positions, because I say they might need to be factored into any corrections that we make. So that was my assignment. Not a big fan of this assignment. I think I sort of did pretty well given all the claims. Like we had like 8 claims and they were not good. I really didn't like them. But I think GPS is probably a pretty common one that you guys will get. But that is how you should do the Physics IA3, and that is how you can get a 20 out of 20. But thank you for watching, and if you have any questions, please comment them and I will respond.